Okay, welcome to your second half of N3 rational numbers. This is taken from chapter 2.1 in your MathLinks book, and we are continuing with the comparing rational numbers in different forms. And in this particular question, if I grab my highlighter here, we have a negative fraction, we have a repeating decimal, we have an improper fraction, we have another negative fraction, and we have a whole number. Okay, so those are all four different types of, or five different types of rational numbers. And our job is to write them in descending order. And as we said before, in order to compare two numbers together, whether it's rational or irrational or whatever, you need to have them in the same form. So what we're going to do with these is we're going to change them all to decimals. So the first one, negative 3/8, will become a decimal through division. I say 3 divided by 8 is one way to do it, and I get 0.375. If I close that, 0.375, which is negative. Now, alternatively, you could have gotten the decimal without using a calculator. You could have created an equivalent fraction uh, with a base 10 denominator, either 10 or 100 or 1,000. And when your denominator is 8, the reason why we choose 1,000 is because if you multiply it by 125, you get 1,000. And if you multiply this by 125, you create an equivalent fraction of negative 375 thousandths. So without division, you could have actually changed that fraction into a decimal through that process, or if you had a calculator, just divide the numerator by the denominator, and it's the same thing. But that's just an FYI moment. Second one is 1.8 repeating, which we're going to, since this one has 3 decimal places, we're going to keep 3 of those repeating decimals, just so we can kind of compare them a little bit better. And that is positive, so we're going to keep it right there. The next one is 9/5, which again, if we take our calculator, 9 divided by 5, we've got 1.8. And again, if we don't use our calculator, we can create that equivalent fraction with the base 10 denominator, which in this case would be 18 tenths, which is 1 8/10, which would end up being 1.8. So you could do it without a calculator. Okay, and your next question. I don't think anyone probably had difficulty with negative a half because it's negative 0.5. You didn't have to do much thinking with that one. And even less thinking with this one because it stays a whole number. Now remember, we're going to put 2 insignificant zeros on that to be able to compare it. 2 insignificant zeros on that. If you want, you can put 3 insignificant zeros on that. It doesn't really matter, but we'll just keep it like that. Perfect. Now, we're going to write them in descending order. So descending order means we're going to go from the largest number to the bottom to the smallest number. So I don't know if this was on purpose, but we have our largest number is 1.8 repeating because that's the largest positive number. Our next largest would be 9/5. Notice how I didn't write 1.800. I put it back in the original form, which was a mixed or an improper fraction. And then as we get to the negative numbers, the closer a number is to 0, the larger it is. So negative 3/8 would be our next largest. Negative a half would be our next largest. And finally, our smallest number is simply negative 1. And that is your answer to rearranging those 5 rational numbers in descending order. Question number 10 is quite possibly the easiest question out of all the ones we've given you. And it just says express each fraction as an equivalent fraction. And there are infinite answers you could give. So for A, in order to create an equivalent fraction, and we'll start with just an easy one first. Before we get to A, I'll just give you the easiest of them all because it's the easiest to see its equivalency. If I asked you what is an equivalent fraction to a half, you know you create equivalency by multiplying or dividing the numerators by a denominator by a common number. So if I multiplied it by 2, for example, which is the most common multiple, I would create this fraction 2 out of 4. And most of us would see 2 out of 4 as being half of something. So if you had 2 out of 4 on a test, you got 50%. If you had 1 out of 2 on a test, you got 50%. If I chose to multiply it by 10 instead, I would end up with 10 over 20, which is still equivalent to 1 over 2, etc., etc. And I can do this with any. In fact, I could divide these two by let's go with all right, 5, whatever, because both are, and I get 2 over 4 again. So you can multiply or divide to create equivalency with any fractions. With these ones here, if I go to A, obviously if I'm given this fraction, negative 2/5, what I would like you all to do first, and it's just more of just a continuity of thought, this is a negative 2/5 or a negative 4/10 or a negative 0.4, whatever you want to think of it as. But I always put my negative symbol in my numerator, okay? That's a good way to always keep it there, because now when you create equivalency with it, if I put this up here, I'm going to do the same thing I told you before, multiply by a common number. The easiest one to multiply it by is 2, and therefore, 2 up here. And therefore you get negative 4/10 as your equivalent fraction. Now if you wanted to, you could write it like that if you wanted to, but that's probably the most common. Just out of curiosity, how many of you put negative 4/10 as your equivalent fraction? Over half of you, right? Makes sense. Makes sense. But there are infinite values. You could have negative 6/15. You could have negative 20/50. You could have negative 200 500ths, etc., etc. The second question B gives you the improper fraction of 10/6, or the ratio between 10 and 6. How many of you use division here to create an equivalent fraction? Good. So instead of multiplying, you could actually divide here by 2, and you could get 5/3 as your equivalent fraction. Now, alternatively, you could have multiplied by 2, which some of you probably did, or if not most of you, to create 20/12. Those would be equivalent fractions as well. Probably over half of you have one of those two fractions, I would suggest, probably. Question C, again, you have that negative symbol here. Just slap it in with the numerator here. So I'm going to rewrite it as I do it here, negative 9/12. You may choose the multiple. How many multiplied to create an equivalent fraction? How many divided to create an equivalent fraction? How many didn't do the question? All right, about 1/3 of each. I'm going to use division because I'm looking at this and I'm saying what number is divisible into both 9 and 12? The answer is 3. So my equivalent fraction would be negative 3/4. That is one equivalent fraction and probably the most popular of choices. I could also multiply by 2 and get negative 18/24. And finally, question D, negative 4/3. If I look at negative 4/3, that is a negative improper fraction. Since it doesn't look like I can reduce it, I'm not going to use division here to create an equivalent fraction. I am going to use multiplication. In this case, I'm just going to multiply by the simplest factor of 2 to create the equivalent fraction that 95% of you had, which is negative 8/6. Negative 8/6. Did anyone go with the negative 1 1/3? Just change it to an equivalent fraction that's not improper. Did anyone go that path? You did? Smart. Anyone else? Just one person? These are equivalent fractions, just in completely different form, improper to mixed. Very smart if you did. Okay, question 12. Which value in each pair is greater? So here we have fractions. You have two options. You can create equivalent fractions that have the same denominator, in which case A and B do not have to be put into decimal form because you can compare them this way. Now, A is like the easiest question ever. A positive value compared to a negative value. Regardless of what the denominators are or the numerators are, a positive value will always be greater than the negative value. So we know that 1/3 is going to be the greater value in those two numbers, regardless of what they are. So the first question, 1/3 is the greatest. In the second question, we have the same type of question. We have a negative 9/10 and we have a positive 7/10. So right off the bat, since that's not negative, that has to be the greater value because it's positive. So far, 50% of these questions are absolutely, unequivocally the easiest things you've ever done. Question C is the first question that requires some amount of thinking. So we have two fractions. You have two choices. You can change them both to equivalent fractions with the same denominator or decimal form. Against my better judgment, I'm going to create equivalent fractions. Okay, so negative 1/2 is negative 5/10. Negative 3/5 is negative 6/10. Again, when we are dealing with negative numbers, if this is 0 and this is negative 1, the farthest a number is from, that's negative 5/10 there. That's negative 6/10. farther a number is from 0, the smaller it is. So therefore, which number is greater? Negative 1/2 is greater because it's closer to 0 as a negative value. And finally, the last question, negative 2 1/8 and negative 2 1/4. We're going to change these ones to, actually, we'll go back here for a second. We could have went negative 0.5 and negative 0.6, and we would have had the same type of number line. So you could change them to decimals. And your last question, negative 2 1/8, is going to be negative 2 1/8 versus negative 2 2/8. All right, so if we think of our number line, 0, negative 1, negative 2, negative 3. Negative 2 1/8 would be here. Negative 2 2/8 would be there. Which one's farthest from 0? The second one is, so therefore this number is greater because it's closer to 0. We're going to skip question 13 and go right on to 15 because question 13 and the one previous were the same type of question. This is where it gets a little complicated. It says identify a decimal number between each of the following pairs of rational numbers. So we're looking for a decimal. So because we are given fractions and we're looking for a decimal number, the easiest course of action is to change both of these fractions into decimals. Now some of you know that 3/5 is decimal 6 and 4/5 is decimal 8 because 3/5 is 6/10, blah, 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 blah. But if you don't know, grab your calculator. What is 3 divided by 5? It says 0.6. So we just change this to 0.6, comma, 0.8. And once we have that, what's a decimal number that's between there? Well, right off the bat, the most obvious one is 0.7. That's probably the one that most of you put. But there are how many different choices? Infinite choices. 0.61 is another decimal you could put there between there. 0.674 is another decimal. 0.79 is another, etc., etc. But the most common one that most of you probably chose was 7/10. The next question, negative 0.5 is the decimal form of negative 1/2. And 5/8, again, just to remind you of that denominator of 8, if you want to change it to a decimal without using a calculator, the equivalent fraction is this, which is 6/25, which is negative 0.625. So we'll put that as negative 0.625. Name a decimal between there. Again, just like what we did in the first couple questions, we put a couple more insignificant zeros there if you need them. You don't need to have them. There are infinite decimal values between there. The one I'm going to choose is negative 0.6. Negative 0.6 is between negative 0.5 and negative 0.625. How many chose negative 0.6 is there? Yeah, most of you probably did. Most of you probably did. Next question. Now this one's going to be an interesting one because 5/6 is a fraction. When we change that to a decimal, it actually is a repeating decimal, 0.83 repeating. So negative 0.833 ... and 1. Think about the number line if you want. 0 is here, 1 is here, negative 1 is here. This number would be somewhere around here and here. So what's a whole number between there, or what's any number? How many of you chose 0? Did anyone choose 0? Why not? Isn't 0 the easiest of them all? Does it say decimal? How about 0.0? Okay, never mind. How about this one? This would be 0.5. Did anyone choose that one? Okay. How many chose negative 0.5? Anyone choose that one? Etc., etc. There are infinite values that you could choose. Any one of those on the number line between those two red dots would work. And finally, your last one, 17/20. If I want to change that into a decimal without a calculator, I can multiply both numerator and denominator by 5. That's 85/100ths, which is 0.85 or negative 0.85. Double check with a calculator. 17 divided by 20 is 0.85, so we're good. Negative 4/5 is negative 0.8 because 4/5 is equal to 8/10, and 8/10 is 0.8. So I'm going to put an insignificant 0 here to help me think this through. What's a decimal between those two? anything probably 0.81, negative 0.82, dot, to negative 0.84. And 83 would be working as well. And you could also go with negative 0.812, 813, 814, infinite values. Appropriate. And the last question, which is the opposite of the last one, this time you're given the decimals and you're asked to find a fraction. So we're going to pursue it the same way we did before. I'm going to interpret those two decimals as fractions. So that's 2/10, which is 2 over 10, and 3 over 10. And when I look at that, I'm finding it hard to find a fraction between it. But if I created two equivalent fractions, and instead of saying 2/10, I said 20/100ths, then I now know that I could use 21/100ths, 22/100ths, dot, all the way up to 29/100ths. But there are infinite values there. That's one way to do it. You can change the decimals to fractions, create them as equivalent fractions with larger denominators so you can find something in between. As long as the denominators are the same, you can compare them. Another way you could have done that to find the fraction is say, well, 0.20 and 0.30 are decimal forms. Choose a decimal that's between there. In this case, I'm going to choose 0.21. That's between there in decimal form. And then think about this as being 21/100ths, and you have your answer. Right? Think of it first as a decimal that's between the two decimals, and then rethink that decimal form as a fraction, and you have your answer. So either way will work. You can convert the decimals to fractions, then equivalent fractions. I particularly find this way to be an easier one to answer the question. Just rethink them as decimals, and then put an insignificant 0 on the end of each, and then you'll be able to do it. If I think about this one, question B, think about zeros being here, and -1 being here. -1/10 is here. So if I think about any number, I'll put just this. I'll put a 0 there. So between 0 and 1/10, if I think money here, -10 cents. What's between -10 cents and nothing? Well, you can go with -9 cents, -9 cents, -8 cents, etc. Those are in decimal form. If I take that decimal form, that's right, and think of it as a fraction again, that's -9/100ths. And therefore, that is a fraction that exists between those two numbers. Okay. Now, question C is really easy, isn't it? What is a decimal that fits between those two, Peyton? Yes. Let's just look at this one here. Just tell me a decimal that fits between those two decimals. I think everybody on the planet, regardless of your ability, knows that that decimal is between those two, correct? But the job is to find a fraction. So then we're going to say, well, what number is that? That's -75/100ths. So that is the answer. That's probably the answer most of you should have. Or if you reduced it to lowest terms and you wanted a cookie, you could say -3/4, right? So -3/4 is taking that fraction that this is an acceptable answer, and you're just applying your reduction skills to make that the answer. And the last one, D, is a little bit trickier because it's hard to find a decimal between there. So when you have this question here, what do you think I'm going to tell you to do to be able to find a decimal between those two? What do you think, Lilydale? Okay, go ahead. Correct. If I place a 0 on the end of both of those numbers, I now am able to think of a decimal between -520 thousandths and -530 thousandths. I'm going to choose right between it as -525 thousandths. Excuse me, that's right between it. And then I'm going to reconstitute that to a fraction, -525 thousandths. Right? Everybody good with that? No problems?